Good morning, children. How are you all? Hope all are keeping fine at home. Today, we are going to start our online classes. Due to this pandemic situation, we are not able to take regular classes in its usual form. So, definitely there will be some problems. Even if you are taking the online classes also, there may be a chance of some communication gap. I am not able to see your faces. I cannot find how you are understanding, whether you are getting anything or something like that. Then there will be a communication gap. So then also we have to go for this online classes. If there is any problems, if there is any doubts, hope you can ask to me and I could help you through the online technologies like WhatsApp, Parent and all. So once again, I welcome you all to the new class, 8th standard. Our new chapter is rational numbers. The first chapter, rational numbers. So maths is always starting with the numbers. Here, whenever you are listening my class, whenever you are attending the class, you have to be ready with a book and pen with you and a pencil with you. Better you should have a 200 pages notebook, rolled or unrolled, no problem. But better unrolled notebook you have to keep with you. And I hope most of you collected the textbook, so that is not a problem. You will be having the textbook with you. So let us begin our chapter. In mathematics, usually we come across with a simple equation. In lower classes, 7th standard and 6th standard, we studied how to solve a simple equation. When we deal with a simple equation, for example, x plus 2 is equal to 3. This is a simple equation. And you know how to solve it. Solving a simple equation means find the value of the variable in it. If the variable is x, so find the value of x. How can we find the value of x? We should remove the 2 plus 2 from both sides to get the value of x. Otherwise, you just transpose the 2 to the next side. So, we will get x is equal to 3 minus 2. That is equal to 1. X is equal to 3 minus 2, 1. And we know that 1 is a natural number. When you are solving this equation, we get x is equal to 1 is the solution of this simple equation, and 1 is a natural number, and here 2, 3, that all natural numbers. And we studied already the set of natural numbers. The numbers which we are using for counting is called the natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. The biggest natural number is nobody knows. There is no biggest natural number. Every time there will be a greater number. So the set of natural numbers are infinite. Infinitely it is going on to one side. The biggest one is infinite. And the smallest natural number is 1. So that is set of natural numbers. Then when we are dealing with the next set of equations, another type of equation, another example I will show you. Second example, x plus 5 is equal to 10. X plus 5 is equal to 10. X plus 5 is equal to 5. Let us see. An equation x plus 5 is equal to 5. In this equation, if when you are solving this equation, what you will get? X is equal to transpose this 5 to the other side. When we transpose 5 to the next side, it will become minus 5. So x is equal to 0. But if there is only set of natural numbers, 0 is not there. So we need 0. So if you include this 0 to this set of natural numbers, we will get another set of numbers. That set of numbers is called the whole numbers. So natural numbers, here natural numbers we use. Natural numbers start from 1, 2, 3, etc. Then in this type of equation, we need only natural numbers. But when we are dealing with this type of equations, so x plus 5 is equal to 5. That means x is having a value that is 0. When x is 0, this equation satisfies. So we need 0. That 0, if you are adding with the set of natural numbers, we will get another set of numbers. That set of numbers is called whole numbers. Whole numbers. So whole numbers 0, 1, 2, 3, etc. So biggest whole number is infinite and the smallest one is 0. Smallest natural number is 1. So along with the natural number, if you add 0, 0 is also included in the set of natural numbers, then that becomes the set of whole numbers. Now let us see another type of equation. These are natural numbers and whole numbers. Then third example, another example. So x plus 5 is equal to 4. X plus 5 is equal to 4. In this, if you solve this equation, what will be the value of x? X is equal to 4 minus 5. X is equal to minus 1. X is equal to minus 1. So in this, until now, we studied natural numbers and whole numbers, and in the set of whole numbers there is 0. There is 0. But here, in the set of whole numbers, we cannot find a minus 1. So we need minus or negative numbers to learn these type of or solve this type of equations. So if you include the negative numbers along with the whole numbers, we will get another set of numbers. Do you know what is that? You study it. What is it? Integers. Integers is the next set of numbers. That means along with whole numbers, if you are adding the negative numbers, so if you are drawing the number line, it will be like this. In the middle, there will be 0, and towards right, the positive numbers, positive integers plus 1, plus 2, plus 3, etc. And towards left, it is negative 1, negative 2, etc. This set of numbers, this number line, the numbers including negative integers, negative numbers and positive numbers along with 0 is called a set of integers. So we will see another type of equation. Different types of simple equations we are discussing now. So already 3 simple equations we solved. From the first solution we got natural numbers. From the second simple equation we got whole numbers, and from the third one we got integers. We understood the need of integers. So in our day-to-day life we need negative integers also, negative numbers also. Next, one more simple equation let us see. That is 2x is equal to 3. It's a very simple equation. And another one, 2x plus 7 is equal to 0. 2x plus 7 is equal to 0. Two simple equations are there on the board. Suppose if I am solving these simple equations, the first one, 2x is equal to 3. If you transpose 2 to the other side, x is equal to 3 divided by 2. And second equation, if you solve the second equation, 2x is equal to, take 7 to the other side, 0 minus 7, so minus 7. And x is equal to minus 7 by 2. So look at these two examples. Whenever we are solving this equation, what is the result? The first case, it is 3 by 2. Is it an integer? No, it is not an integer. It is a fractional number. And second one, is it an integer? It is not an integer. It is not a whole number. It is not an integer. But it is a fraction. You already studied fraction in lower classes. So when you discuss with the numbers, when you study the numbers, then integers, natural numbers, whole numbers, only that is not enough. We need some more numbers, some more set of numbers. Other than this natural numbers, whole numbers and integers, we need few more extra numbers. The numbers, they are not, which are not integers, whole numbers and all. Also there exist some other numbers. We call sometimes fractional numbers. So that type of numbers also included in the set of rational numbers. So what is rational numbers? The rational numbers are the numbers which includes these type of numbers also, along with natural numbers, whole numbers and integers. These type of fractions also included in the set of rational numbers. So we can see the definition of a rational number. So I think you understood the concept of rational numbers. So first in lower classes you studied natural numbers or counting numbers that start from 1, 2, 3 and all. Then whole numbers 0, 1, 2, 3 etc. And integers, it includes negative numbers. Now comes to the portion rational numbers. Rational numbers are the numbers which includes some fractions also, decimals also will come in that. So that are called rational numbers, and it's a definition. If you are defining rational numbers, I write the definition of a rational number in the board. The set of rational numbers are defined as the numbers that can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. That is the definition of a rational number. The number this is what is the definition of the set of rational number. A number is said to be rational if that number can be expressed in the form of P by Q, where P and Q are integers and Q not equal to 0. Means if you look at the set of natural numbers, we can say that every natural number is a rational number. Why? because every natural number can be expressed as p by q, where p and q are integers. For example, 1 is the smallest natural number. 1 can be expressed as 1 by 1, and in the place of p there is 1, in the place of q there is 1. So 1 is an integer, this one also is an integer, and this also can be 1 also can be written as 2 by 2. 2 by 2 is equal to what? We know the value. So 2 is an integer, and this 2 is an integer, and this 2 is not equal to 0. Why it is not equal? Why there is a clause that q not equal to 0? If q is not equal to 0, if q is equal to 0, that number is not possible. Division with the 0 is not defined. So we cannot divide by 0. That is, in the definition of rational number, if p by q is a rational number, p and q are integers, q must not be 0. If q is 0, the number is not defined. There is no value. For example, 2 by 0. Actually, 2 is an integer, 0 is also an integer, but it is not a rational number. What is the reason? Q must not be 0. The denominator must not be 0. If denominator is 0, the number is not defined. There is no such a numbers. So that is the definition of p by q. Any natural number if you take, we can say that natural number is a rational number. And if you take a whole numbers, 0, other than natural number, in the set of whole numbers, other than natural numbers, 0 is also there. And 0 is also a rational number, because 0 can be written as 0 by 1, 0 by 2, 0 by 3, any number. 0 by 1, the value is 0, 0 by 2, the value is 0, 0 by 3, the value is 0. So this 0 is also a rational number, because 0 can be expressed as a fraction in the form of p by q. P is an integer, q is an integer. Understood? So every natural number, every whole numbers also comes under the category of rational numbers. And if you take any integer, in every integers are rational numbers, because minus 1 is an integer, and minus 1 by 1. What is minus 1 by 1? That is also minus 1. So minus 1 can be expressed as minus 1 by 1, and minus 1 is an integer. This one is also integer. So minus 1 can be expressed as p by q, and the denominator not equal to 0. Minus 2 can be expressed as minus 2 by 1. Minus 2 is an integer, and 1 is an integer. 1 is not equal to 0. So any number that can be expressed in the form of p by q, where the denominator q is not equal to 0, is called rational numbers. Okay, next let us see some properties of the set of numbers. We already discussed with the natural numbers, whole numbers, integers, and rational numbers also we defined. And I think it is clear what is rational number. A number that can be expressed in the form of p by q, where p and q are integers and q not equal to 0. Such numbers are called rational numbers. If you look at all this set of numbers, these numbers are having some properties. When we are discussing with the properties of set of numbers, the set of numbers, the properties comes along with the arithmetic operations. The 4 basic mathematical operations, addition, subtraction, multiplication and division. When you are performing these 4 mathematical operations in this set of numbers, then we can see some properties. Some properties are there. Among that, the first property we are going to discuss today is the closure property. First property. properties of numbers. Numbers. I'm just writing numbers. Actually, it is not just numbers, the set of numbers. That is natural numbers, whole numbers, integers, and rational numbers. In every set of numbers, some properties are there. Among them, the first property, closure property. Closure property. What is meant by closure property? When we are saying closure property, along with it, we have to consider the mathematical operations I told you: addition, subtraction, multiplication, and division. Separately, each one we can discuss. The first one, addition. Addition. Closure property. Let us see the set of whole numbers. Closure property is set of whole numbers with addition. If you check whether addition is closed in the set of whole numbers or not, how can you check? Closure property means, if closure property of addition means, if we are adding any two whole numbers, the result, the answer is also a whole number. That is the closure property. If you are adding, is it clear? If you are adding any two whole numbers, the result or the answer also will be a whole number. The sum will be a whole number. That property is called a closure property. So, for example, if you are adding two whole numbers, 0 plus 1, we know that 0 and 1 are whole numbers. If you are adding these two, what is the answer? Simple, it is 1, and we know that 1 is a whole number. And if you are adding 2 plus 3, 2 and 3 are whole numbers, and the result is 5. 5 is also a whole number. So, if you take any two whole numbers, any big whole number or any small whole number, smallest is 0. When you are adding the two numbers, the result, the sum will be a whole number itself. That property of whole numbers along with addition is called addition is satisfied, addition is closed in the set of whole numbers. We can say that addition, the operation addition plus the operation addition is closed in the set of whole numbers. So to check whether whole numbers is closed with the addition, you just check any two whole numbers and add the sum. You check again, the sum is a whole number. That means the set is closed with the addition. Clear? The next one, subtraction, we can check. This is first operation. Second one, subtraction. Subtraction. How you think whether subtraction is closed or not? What do you think? Subtraction, any two whole number you take, say 3 and 2. 3 minus 2 is equal to 1. Here 3 is a whole number, 2 is a whole number, 3 minus 2 is equal to 1. The result, the subtraction, the difference is also a whole number. But does it occurs in all cases? If you take any two whole numbers, whether it is it possible or not? Suppose 5 minus 7. 5 minus 7. When you are subtracting 7 from 5, what is the answer? 7th standard and 6th standard you studied integers. So, when you are subtracting a big number from a small number, you will get negative numbers only. So, the answer is minus 2. Here, 5 and 7 are whole numbers. When you subtract 7 from 5, you got minus 2, and minus 2 is not a whole number. Minus 2 is not a whole number. So we can conclude that subtraction is not closed in the set of whole numbers. So closure property is not satisfied in the case of subtraction in the set of whole numbers. But addition is closed. Any two whole numbers, if you add, you will get a whole number. So addition is closed. Subtraction is not closed. Now see next step. Operation. What is the next operation? Multiplication. Third one. Multiplication. Multiplication is closed or not in the set of whole numbers. You can say two whole numbers. Example, 0 into 2. 0 is a whole number. 2 is a whole number. 0 into 2 is also 0. Any number multiplied with the 0, the product will be 0. So when you are multiplying 0 into 2, you will get 0. Any two whole numbers, if you take, here in this case 0 is a whole number, 2 is a whole number, and 0 is the product 0 is a whole number. And another number 1 into 2. 1 and 2 are whole numbers. The result is 2. Again, the result is a whole number. 3 into 5. 3 5s are 15. 3 is whole number, 5 is whole number, and the product is 15 is a whole number. So whenever we are multiplying any two whole numbers, we are getting the product, and the product will be a whole number only. So we can say that in this set of whole numbers, the operation multiplication is closed, or the closure property in the set of whole numbers along with the multiplication is there. So multiplication is closed in the set of whole numbers. And let us see the division. Division, what do you think? Is it closure closed or not? Division is closed or not? How you think? Okay, fourth one, division. When you are dividing a whole number by another whole number, the answer sometimes only whole number, and sometimes the division is not possible also, in which case you cannot divide a whole number by 0. 2 by 0 is not possible, isn't it? 2 divided by 0, is it possible? No, it is not allowed, it is not defined. So first itself we can say that the division is not closed. Some other examples also you can take. 2 by 0 is not possible, any number by 0 is not possible, but 2 by 1 is possible. 2 divided by 1, that is 2 divided by 1 is equal to 2. Here 2 is a whole number, 1 is a whole number, and 2 is the result is whole number. And 4 divided by 2, you will get 2. 4 is a whole number, 2 is a whole number, and 2 is a whole number. But only in some cases we will get the result as whole numbers. But here 5 divided by 3, is it a whole number? The answer will not be a whole number, it will be a fraction. 5 by 3. If you divide it, you will get a decimal only. That is not a whole number. So we can say that in the set of whole numbers, division is not closed, or division is not closed in the set of whole numbers. So let us see the property of numbers we discussed with the whole numbers. We already checked the 4 operations: addition, subtraction, multiplication and division. Among these 4 operations, addition and multiplication are closed in the set of whole numbers, but subtraction and division not closed in the set of whole numbers. And the remaining properties, and the same closure property we have to check with the set of integers and set of rational numbers and all. That how we will do in the next class. Thank you.